The IT labor market is slightly getting more and more competitive as there is more demand than supply of professionals. And of course, every company wants the best of the best. But spotting them and ensuring they actually fit in the organizations needs for loads of time, effort, and also software and diagnostic testing investments. I want to shorten recruitment times as well as reduce psychometrics testing costs, starting with personality tests. I'm Miguel Garcia Melgar, and I'm going to talk to you about natural language processing to predict Myers-Briggs personality type. But what's this Myers-Briggs things, might you wonder? The MBTI, Myers-Briggs Type Indicator, is a personality test that from the combination of the four bipolar dimensions you see on the screen leads to 16 different personality types. I've been working on a calculus dataset which contains two categorical variables about almost 9,000 users from Personality Cafe Forum, the four letters codes of their personality type, and a section of their last 50 posts and comments. When I started exploring the data, the most notable thing I noticed is that it has an enormously unbalanced distribution, something that could be a problem. We'll see if it really turns to be a blocker or not. First of all, for the pre-processing of the data, I cleaned and lemmatized the tests using the library called Spicy. What does lemmatize mean? It is the process of turning a term into a lemma, the representative of all the flexed forms of the same word. Subsequently, I vectorized using TF-IDF vectorizer. In other words, I converted the document corpus, in this case the result of lemmatizing, into a special representation, a vector matrix. Once I got that matrix, I tried several dimensional reduction methods to conserve only those vectors that seemed most relevant to my problem. I built several machine learning models using the different dimensionality reduction methods and a manifold of algorithms. I also tried to model with deep learning in the Zinglov and a long short-term memory neural network. And also for all those models, I tried to predict types, and also I made alternative models to predict the poles of each axis. In addition, I also had a version of each, using the original sample and another one using an undersampled one. The best results for both types and axes came from using gradient booster classifier on the outcomes of reducing to 100 components with truncated SVD from the original sample and without any sort of resampling. But how does this algorithm work? Gradient booster classifier is a classification algorithm, as the name says, that assembles decision trees sequentially, and then it weights its estimates for each variable based on the estimation errors of previous trees. And those are the results. As you see, they are focused on F1 score. Why? Well, I use these metrics since I am not more concerned with exhaustiveness than precision, or vice versa. Furthermore, it is less sensitive to overfitting than accuracy, especially in its weighted form. I also decided to emphasize the results obtained with the types against the axis, since to predict type with the latter, it would be necessary to make 4 consecutive predictions, reducing the probability of success. In any case, if you really want to predict the result of a single dimension, then the models based on this dimension will be better. Once a model was chosen, it was time to proceed to its hyperparameters tuning. As you can see, after doing so, F1 score improved a bit. To sum up, I have obtained a model that is capable of discriminating better than a 16-sided die. But why better than a 16-sided die? Because we are working with a multi-class target variable of 16 classes. Given an even distribution throwing a dice, the hit rate would be around 0.0625, while that of my model would be of 0.6519. This model's predictions is about 10 times more accurate. For further improvements on this project, I will first of all work more on its hyperparameters. As for time and computational reasons, I tested the model's hyperparameters using research CV in pairs or triplets, and I would really like to try them all at once. I also want to train a model with a more balanced sample and then test it on a completely different one in order to see how the Badley distribution may have affected my model. Finally, I would like to train a model based on this one but using results from the Big Five model, because its test is the personality measure with highest predictive validity. Thanks a lot for your attention. If you want to know more about this project, you can find the code at the GitHub repo linked here or contact me through LinkedIn.